In this example, we want to create a whole station, including transformer, switchgear and low voltage distribution. First of all, we load a background map. You can find it in the directory where the software is installed. In the map, we can see the position of the single elements, which means we simply insert them by mouse. The transformer can be taken from the library, as you can find it there. It's only necessary to know the most important parameters, such as the voltage, the kind of insulation, the short circuit voltage and the power. The low voltage distribution can be taken from the library too, and the cable field of this example as well. If you are working with a special cubicles, it may be possible that you don't find them in the library. In this case, it's necessary to model the cubicles based on technical plans, but then there's a possibility to save them in the library to reuse them for following projects. Now we want to start to connect the single parts of the station. For this, we draw a polyline in the place where the cables are supposed to be later. Initially, all the conductors are inserted in the same plane. After finishing the polyline, push the right mouse button and you will see a dialog where you can change parameters of the conductor. Obviously, we also need a connection between the low voltage distribution and the transformer. To put the connectings to the right height, change your view in order to see what you are doing. We choose the function stretch to make this connection. We repeat this step twice, once at the low voltage distribution and on both sides of the transformer. Then we create a cable from the polylines. If the function AutoConnect is activated while constructing a cable, every loose ending of a cable will be connected with the closest conductor that has the same phase. The last step will be the distribution of currents. You don't have to enter a value for every single conductor in the geometry. The software is doing this job for you. The only thing you have to do is to set the currents on the feeding conductors and the value of transmission, 380 ampere in this example. The minus sign is necessary because the current leaves the system. In order to select the whole geometry, make a double click and then choose the function correct Kirchhoff law. Starting from the active conductors, every element is given a value of current. Finally, we start the calculation of the magnetic field, since the electric field is not important in station, because it's usually shielded by the station walls.